SN1 reaction looks to have a polar solvent because it's a first order reaction, and it normally just depends on it does you put this molecule into an appropriate environment. Less charge separated is generated in the transition state, SN2. Strong solvation may weaken the strength of the nucleophile because of the energy needed to strip off the solvent molecules. Okay, if I want to go to one of those fancy restaurants, okay, I got a waiting list, right? I have trouble getting in. Okay, I want to go to those fancy discos. I have trouble getting in. I got to know somebody. I get online. I don't want to have to go through that trouble.
Well, isn't it more like putting a rock star in the middle of a snack club?
Yeah. There's two. I need his. I want an autograph. I want Doug Henning's autograph. I can't get to him. There's too many people around me. Okay. I'm gonna be. I can't fight my way through. Okay. A strong solvent is going to weaken the strength of the nucleophile. So if I'm using water, which is a polar molecule, okay, it's going to highly solvate my substrate, and I can't get to the substrate. Thus, SN2 reactions go faster in these strange type of solvents. Okay, these solvents, they have these weird names. Okay. The slow step of SN1 reaction involves formation of two ions. Salvation of these ions is crucial to stabilizing them and lowering the activation energy. Okay, chemists and physicists at this point, you probably know from chemistry too, they always talk about things happening in the ground state, or lowering the activation energy, or having this low delta G. And when you go on to take advanced organic, okay, then you'll talk about these reactions in terms of that. Okay? The solvent may be heated to reflux, effects of the solvent. What's this? What does that look like? What kind of distillation is this? That's right. It's the same as this. Yeah. That's what Rob's class can do. The transition state. You laughing?
Oh, it's fine.
You laughing at my transition state? What reaction is this?
SN1.
SN1.
No.
What reaction is this? SN2. What type of molecule is this? It's a methyl something. It's a methyl chloride, methyl bromide, or something, right? Transition state. This is SN. Has a transition state. SN2. There's only one minus charge. It doesn't have that double plus thing. Aprotic solvents. These are the more popular ones. On dioxide. Huh? Which one?
That's a common one. Oh, and dimethyl sulfide.
Right.
Hexamethylphosphorus.
This one you might see later. Looks like water, kind of, right? Right? Except these are hydrogens, and that's the oxygen. Okay? So it's going to behave kind of like water. Bond angle is a little smaller than water, right?
But the important thing is there's no hydrogen.
This you'll definitely see later. You'll definitely see this one later.
He's not kidding. You're going to be like an all-Argo too. You use tetrahydrochloride as a solvent, doesn't she? You use tetrahydrochloride.
one, I need a good ionizing solvent. A good ionizing solvent is required for this one. A less polar solvent.
Polar aqueous.
The rate of SN1 reaction is proportional to the concentration of the alkyl halide, but not the concentration of the nucleophile. That goes first order. The rate of SN2 is second order. So for SN2, I need a strong nucleophile and a weird solvent. I need a strong nucleophile and a weird solvent to occur. SN2, I'm going to have one of these aprotic solvents for this. SN1, first order. SN2, second order. The SN1 reaction involves a flat carbocation intermediate that can be attacked from either face. This results in a racemic modification, meaning that I can have something that rotates the plane of polarized light, D or L dextrorotary or levorotary. There are two forms of glyceraldehyde. One is dextro, levo, and it's RS. When it carries out an SN1 reaction, it no longer rotates the plane of polarized light because of the transition state. An SN2 reaction will produce a product that still rotates the plane of polarized light.
I'll give it to you at 20. I'll give it to you at 20 minutes.
However, there will be a complete inversion of configuration. So in SN1, there's a mixture of retention and inversion in the racemate. SN2, complete inversion. There are rearrangements that can occur. There are rearrangements that can occur for SN1. Did Dr. Clement discuss that? She talked about that? When I had this course, SN2, there's going to be no rearrangements at all. An example of reaction taking place with SN1 mechanism is the hydrolysis of terpbutyl bromide. It's tertiary in water, a regular solvent you heard about, okay, forming terpbutyl alcohol. So I'm taking an alkyl halide and I'm making an alcohol. If I have a company that makes this, I make a lot of money, right? Rubbing alcohol. I'm making terpbutyl alcohol is also 2-propanol, okay, right? Formation of terpbutyl carbocation separation by a leaving group, the bromide ion. All I need is to put this in a good solvent for this to occur. This is something that I remember from 25 years ago. Is a hydride shift. There's a hydride shift and there's also a methyl shift. So if you didn't do this yet, you'll do this next week. If a protonation occurs, if I protonate something, I add an acid to something, I can dehydrate it. Normally, when I add an acid to something, I have an excess of hydrogen, and I can grab OH, form a water, and the water will leave. When that happens, I form a carbocation. This carbocation is secondary, tertiary, primary, Melba? That's correct. After a hydride shift from